Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will talk about how to reduce from an ER model or an entity relationship model to an schema of the relational database. Now we will describe that how to represent the strong entity sets by the simple, complex and this of the attribute. And we will also see that how to introduce an relationship set into the relational schema, how to depend on the functional dependencies, combine the relationship sets as well as discrete or decompose the relationship sets. When we talk about the ER model, that is for the designing part of that database as its overall logical decomposition or in a part. Now, actual implementation of the database needs to define the schema or the structure of the database. And with the help of the ER model, we can make the schemas. Now, when we talk about a relational schema, so we need to reduce it from the ER model. So the first thing that we need to consider is the representation of a weak entity and the strong entity set one by this attribute. So first, the strong entity set using the simple attribute. When we represent a strong entity set, that has got a primary key which is at its definition. Now, if we represent it as a simple attribute, then we are saying that no complex attributes such as that as the attributes are atomic by nature, we cannot devise the attributes anymore. So we can configure the strong entity sets with simple attributes as the most smooth and simplest idea of having a relational schema. Look at this example. I have made a schema student with the ID, name and total credit. All of these three attributes are simple attributes because ID is the primary key, has got a single value as well as the atomic one, name and total credit too. Next, let's look at this one. Now the department has got the department name, the building budget. The classroom has got a primary key considering the building and the room number and also the capacity. Now all of this complex of these simple attributes, not a composite one. So when we are forming a strong entity set, that is a relation into the schema having only the simple attributes, then we are actually making the most simple relational schema. But it is not possible the case that we can configure the relational schema using only the simple attributes. Sometimes we need to introduce the complex attributes. Now, when there is a complex attributes, the corresponding ER model actually defines and expands it as a part of the attribute, or each of the part becomes an attribute itself. It was more like having the attribute and then dividing the attributes on that part, so that all can be a part of the attribute which is a part of the entity set. Now, how to define it using a relational schema? Well, we can do that. We can divide the attribute names as in the part of that entity set or relational schema at its most, making it in a simple and complex attribute. So if there is an instructor relation and based on its name was the attribute, and first name, middle name, last name can be the derived attributes or the attributes as a part of the attribute. So in the instructor relation, we will include only the most simple attributes that we can add, not the attribute that has got a complex name. Now this way, the ER model representation of a complex attribute can be converted to a relational schema. Now, what happens with a multi-valued attribute? The multi-valued attribute generally get double circled in an ER model. And one example is the phone number. So how to represent it in the relational schema? Say suppose that the instructor has got the name and phone number, or the ID and phone number. Now the relational schema can include the multi-valued attribute as a part of the primary key to the relation. So now our relation instructor so the multi-valued attribute becomes a part of the primary key. Now if the ID got 222 and he has got two phone numbers, so there will be two primary keys, 222 3134357 as well as 222 313 4329. So we can say that there are two phone numbers for the instructor's ID and phone number relation. Now sometimes it is also not possible to make a multi-valued attribute as a part of the primary key. So how to deal with this? Say for a time slot relation. The time slot relation is identified by the time slot ID. We know that. And we have got the day, start time and end time as an attribute to it. But it can happen that two classes meet at the same day at the same time, but their class will end at different times. So the day and time can also be multi-valued. So we have to include this as a part of that primary key. But see that end time has also multi-valued, but we cannot include it in the primary key because it cannot uniquely identify. What I was prescribing, that a same day at same start time two classes has started, that means they got a two distinct information with a multi-valued end time on that particular building. So the end time cannot be included in the primary key even if it is a multi-valued attribute. So depending on the situation, we need to keep some multi-valued attributes as part values of the unique identification keys, so that if there is also multi-value, it will give us a unique record for each of the multi-value of that one which we do not consider as a primary key. Now the next part is suggesting that how to represent a weak entity set. A weak entity set is a set that does not get any primary key. So if there is no primary key to a set, that set is considered to be an weak entity set or a weak relation. So weak relation generally existence dependent on some strong relation. That means a particular relation can exist only if another relation exists. Say for the example course and section schema that we'll look at. Now, the section is entirely dependent on the course. When we are talking about a section, that means there must be some course that is taking on the section. So, the existence is dependent on course of the relation section. We cannot have any section if there is no corresponding course to it. So even if it has got a primary key section ID, we can say that section cannot exist if there is no course lying to it. So it becomes a weak relation. So how to represent the weak relation in this relational schema? First, we need to consider that this is the primary key of course, that is the course ID, but the section ID is not the primary key, rather it is known as a discriminator. We say a discriminator of a weak entity set, the number of or a collection of attributes that actually provides the uniqueness to the relation or the entity set. Here the combination of sec id, same and year marked as a dashed line, not a solid line, is the discriminator of that particular relation section. Now, how to make it in a relational schema? We cannot have a discriminator in the relational schema. So we can combine the primary key of the defining or referring relation with the discriminator of the weak entity relation combining as a primary key of the weak entity relation. So now the section ID will be considered as So this is the relational schema on section that we can make as a primary key of the combination CID as well as the section ID, semester and year of the section weak entity. So if there exists, we can say that A relation on a strong relation B, and if the attributes are A1 to AN, then we can say, and there is a strong entity B which has got B1 to Bn, then we can make a relational schema on A which will have the union of this one as well as this one. Now, if there exists a referential integrity that this one is getting referenced onto another relation. So section is a part of the time slot relation. So if I make a part in it, then it will actually refer to this primary key of the section ID, course ID, semester and year in the time slot without any direct relation to the course. Now we can say that the referential integrity will be made on delete on cascade. So if there is any portion that we want to delete the referential integrity from the time slot, first it will be deleted from the section, and when it is deleted from section, then only the time slot can be deleted from that particular attribute. So we can say that on delete cascade is present in this type of weak entity set. Now we will know that how to represent a relationship set inside an relational schema which were present in the ER model. If there are a set of relationships A1 to AN for a particular relation and the enterprise, and there are descriptive attributes attached with each of the relations, that is B1 to Bn, then for our relational schema we will have a combination of A1 to AN and for B1 to Bn. So if now this is considered as a relationship set and these are the descriptive attributes of a relation, then this can be the resultant schema on the relationship set. Now, what do you mean by descriptive attribute? If some attribute is added to the relationship set in an ER model, just like this. So this is the relation and this is the descriptive attribute. So now this is a part of this. If say the instructor and the student has got the advisor relation, now I want to add a descriptive attribute that on the relation student advisor. Now when we make this, we can say that an instructor can become an advisor only on a particular date when a student has become an advisee to the instructor. So now we can have a descriptive part of the relation date as a part to it. So how can we represent it in a schema? For the binary relationships, there are three parts: many to many, one to one, and many to one. So if this is many to many, then we will consider the primary key of two of the sets as a combination primary key of our resultant relationship sets. So the primary key of R1 as well as the primary key of R2 will be the primary key of R. Now if there is lying a one-to-one relationship set, then also we can apply the same rule that the primary key of one relation that is mapped with the primary key of another relation can has the primary key of that resultant relational schema. But now if there lies a binary many to one relationship, the primary key of the relation or the entity set which has been the many to directing the arrow to the one entity set has become the primary key of the relational schema. So which is the many part, that is many to one, that we can have the primary key as a resultant relational schema. Now, if it is a n-array relationship set, that means if it is considering more than two primary sets, then the union of the all participating relationship sets will be the primary key of the resultant schema. Now finally, if there is an n-array relationship with one arrow indicating to any of the relations, then the combination of primary key of all the other relations subtracting from the one side relation will be the primary key of the resultant schema. Now we also can create a foreign key constraint on the relational schema from two of the relation. Say for look in the example on the ERD that a student and the instructor has got a student advisor relation. Now that we got ID same as the student as both the primary key to the instructor relation as well as the student relation. Now how to make the relational schema and the primary key? So the relational schema on the relationship set advisor will have the primary key of referencing this two and the primary key of the relations. So we may not mention ID as two types of the instructor and student. So we will make SID and IID. So now our resultant schema will have. Now the primary key is consisting the referential integrity or a foreign key constraints on instructor and student, which is the relationship between them. Now there we will consider that each of those relationship sets and how can we make them a resultant schema with the primary keys. So for the student and section there exists a text relationship. So how to define it? The student has got their ID, name and total credit, and the section got the course ID, section ID, semester, year. So the text relationship will be represented as. So the primary key of text like this. Now if we talk about the instructor and section, the instructor has got ID, name and salary, and again the section has got the course ID, the section ID, semester, year. So the teacher's relationship will get exactly the same of the text relationship, and it will look like. Now let's look for the sec-course relation which lies between the section and course. So the section has the course ID, section ID, semester and year, and course has got the course ID, title and credit. So what will be the sec-course relationship looks like? Now that we have know that how to make a relationship to an relationship schema, so we should know that how to redundant schema into a relational basis. So when we are reducing the relational schema, that means we are reducing the number of attributes to it. We can either combine it and make it a larger schema and then check for it that we are actually making a successful and meaningful schema or not. Or we can just split it into smaller schemas to make the decomposition lossless as well as dependency preserving in terms of the relational schema. Now first let us look at some of the relation and check that whether the combination is a valid or an invalid one. Say suppose the instructor and department which has got the ID, name, salary and the department name, building and budget. Now if I combine and make it an instruct department which consists. See, I am left with this only the instructor field, not the department one, because I am making a meaningful schema by making the department as a reference to the department table, that we can have all the information on a department name, building and budget. So we need not to attach it here, the building and budget. We are just using a foreign key constraint department to actually refer to the department table. Now more complexity arises when this type of joining is here. Now the student department relation makes ID, name and department from which we can refer to the department as well as the credit. Now the credit goes to which department? These are the values that is missing from this relation student department that we have achieved by combining the student and department and using as a referential integrity. So we need to keep in mind that we cannot have like this information. We need to make a precise one with the constraint that only a department can have a particular credit. So it is a functional dependency department name to credit that lies within the student department to make it a valid one. Now, if there are shown the lastly total participation and partial participation, how to derive that? If there is a total participation from the right hand side to the left hand side, then means we are actually saying the relation schema will be a combination of all the attributes of a right hand side. Now, if there is a partial participation from the right hand side to the left hand side, then we can say that we are actually having some null values into our resultant relational schema. Now, in this way, we can reduce from an ER model like representing the entity sets within simpler and complex attribute, the weak entity set, the multi-value derived as well as complex attribute sets, the relationship sets, the descriptive attributes, as well as combining and identifying the relational schemas. So now we have reduced to the relational schema. We can now perform all the operations, the joining, the selection, the updation to the relational schema as a part of the database management system. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.